So when we use the unit circle, we want to keep in mind what, again, the ratio of the sides are for these 30, 60, 90 and the 45, 45, 90 triangles. So if you think about it, let's think about that first triangle, the 30, 60, 90. What we remember, grab some color here, is all right, I'm going to call this one 30 and this one 60. And what I always keep straight is I can remember sine of 30 is 1/2. So opposite 30 is 1, hypotenuse is 2, and so that other side is the square root of 3. I can verify this with Pythagorean theorem if I forget, or with a calculator. The 1/2 is easy to see on a calculator. And the 45, 45, 90, again, the legs are each 1, and the hypotenuse is the square root of 2. Okay, so when I look at this, it has, right, the hypotenuse is 1. So if you think about what my sides are, right, so opposite 60 would be square root of 3. We know opposite 30 would be 1, and the hypotenuse 2. So if I want the hypotenuse to be 1, then I'm going to divide 2 by 2, because 2 over 2 is 1. If I divide this side by 2, then I have to divide the other sides by 2 as well. So if the hypotenuse is 1, then this side P is the square root of 3 over 2, and this side opposite the 30-degree angle is 1/2. So if we think of this other triangle the same way, again, the way we think about it is, again, we have that 1, 1, and then this would be square root of 2 for the hypotenuse. But when we look at the unit circle, it's that hypotenuse that is 1 unit. So we divide the square root of 2 by itself, because that equals 1. If I divide that side by the square root of 2, I have to divide the other sides by the square root of 2 as well. And so to answer the question, find the exact values of side length P and R. Side length P is the square root of 3 over 2, and side length R is 1 over the square root of 2. And remember, rationalized, we would multiply top and bottom by the square root of 2, so R rationalized would be the square root of 2 over 2. So we use this when we look at questions like this one. Let me make this a little bit bigger so you can see. And let's take this one down. Here, we'll look at that one next. Okay. So we're going to look at the angle theta, negative 240 degrees. Okay, and so we're going to plot that first in standard position on the unit circle. So remember, standard position means I would start on the x-axis, and so we will draw this, and it's already drawn for you. So we know if we go to here, this is 180. And then these tick marks really represent, if this is 180, this first one is another 30 degrees. The next one would be 180 plus 45. And then the next one would be 180 plus 60. So remember, this is 30, 45, and then 60 degrees up from 180. So that would make this 210, and then 180 plus 45 are 225, and then 180 plus 60, which is that 240. And since we're going in the negative direction, those would all be negative. And so that means our reference angle right here would be 60 degrees. So the reference angle, again, remember that angle made with the x-axis. So now when we're trying to figure out the sides, so like let's read the directions, find the lengths of the legs of its reference triangle. These are labeled A and B, so we see that A and B labeled there when the angle is sketched. Okay, so if this is a 30, 60, 90 triangle, and we're really referencing this 60 degrees right here. So remember, we keep this triangle in mind, our special triangle. So we'll draw it similarly. This is 60, this is 30, here's the right angle, right? So that's how it looks over here. Remember, opposite 30 is 1, 2, square root 3. So if I draw that similarly over here, let me change color. Opposite 60 is the square root of 3. Adjacent to 60 is 1. And the hypotenuse is 2. But just like in the previous example, since this is the unit circle, the hypotenuse needs to be 1. So I divide 2 by itself because 2 over 2 equals 1, which means I also have to divide this side by 2 and this side by 2. So if I'm using that information to find the coordinates of this point P, then that means I would go over to the left 1/2, so that's negative 1/2 if I'm plotting this point, and then up square root of 3 over 2. So that's what we would fill in over here. So side A, which is this side down here, is 1/2. Side B is the square root of 3 over 2, and then that point is negative 1/2 square root of 3 over 2. Let's talk signs here for a second. When we're talking about the actual side lengths of the triangle, and that's what we're talking about here, find the lengths. We don't think of lengths as being negative numbers. So that's why side A is 1/2, side B is square root of 3 over 2, positive numbers. But then when I identify that point, that's when I incorporate the sign, because we'd be going from the origin to the left, so that's negative 1/2, and then up square root of 3 over 2. So now let's use that same information to answer a couple more questions. So we're going to look at this. Let's move this down. Let's make this a little bit bigger. So now we're going to use that information to look at the exact values of some other trig functions. So if we're going to find, we just built the triangle for the angle negative 240 degrees. So now we could find any of the 6 trig ratios of that angle. So cosine of negative 240, remember cosine is the x coordinate of the point, and sine is the y coordinate of the point. We could also think about this with the sides of the right triangle, but let's focus on the unit circle this time. So cosine of negative 240 would be negative 1/2. Because again, remember that point we think of as cosine theta, sine theta. So cotangent, remember cotangent is the same as cosine theta over sine theta. So cotangent would be cosine is negative 1/2 over sine theta, which is square root of 3 over 2. So now we have to think about what we know about how to divide fractions. So that'd be negative 1/2, change to multiplication and flip the bottom. So 2 over the square root of 3. We can cancel those 2's. So this is negative 1 over the square root of 3 rationalized is negative square root of 3 over 3. So what about secant of negative 240? So secant we know is 1 over cosine. So this would be 1 over, we know cosine is, excuse me, negative 1/2. So this would be 1 times, flip the bottom, negative 2 over 1, which is negative 2. So remember, it's important to really remember all of those reciprocal functions. We had 2 reciprocal functions there. So remember that cosecant is the reciprocal of sine. So we looked at it as hypotenuse over opposite, but you can also think about that as 1 over whatever sine is. Similarly with secant theta, we can think of that as 1 over cosine theta. It's also, when you're looking at the right triangle, hypotenuse over adjacent. And then same thing with cotangent. Cotangent you can think of as 1 over tangent theta, or since we think of tangent as sine over cosine, you can also think of it as cosine over sine. Okay, let's tackle this last example. Find the terminal point on the unit circle determined by negative 11 pi over 6 radians. Okay, so let's draw the angle first. So again, it's a negative angle, so we always start on the positive right axis, and then we're going to go this direction. So let's think about this. This would be negative pi over 2. This is negative pi. So this would be negative 3 pi over 2. And then again, this would be the negative 2 pi. I want to think about all of these with a denominator of 6, since that's what we're looking at. So instead of thinking of this as negative pi, I'm going to think of it as negative 6 pi over 6, because 6 over 6 is 1. And instead of negative 2 pi, again, if I multiply by 6 over 6, this is negative 12 pi over 6, because 12 over 6 equals 2. So if going all the way around would take me to negative 12 pi over 6, negative 11 pi over 6 would just be above it. And that means the reference angle would be pi over 6. So this angle here is negative 11 pi over 6. And again, pi over 6 more would take us to negative 12 pi over 6. So my reference triangle would look like this. Remember, pi over 6 is the same as 30 degrees. So if I think of that 30, 60, 90 triangle, again, this is 1, 2, square root 3. Let's label the triangle accordingly. So opposite, remember 30 and pi over 6 are the same. So opposite the 30 degrees, or pi over 6, is 1. Then this is 2, and this is square root 3. Since this is the unit circle, and I'm actually going to be looking for the coordinates of this point, I'm going to divide by 2, so the hypotenuse is 1. So now this is 1. So the coordinates of this point would be, we went over square root of 3 over 2 and up 1/2. So to answer the question, find the terminal point on the unit circle determined by negative 11 pi over 6. This would be that point.